Equipment and facilities exist across the Center for Compact and Efficient Fluid Power to aid fundamental research in fluid flow and tribology for fluid power. Researchers in the high-pressure rheology lab at Georgia Tech study the formation of entrapped pockets of high-pressure liquid in a new instrument dedicated to the investigation of the effect of entrapment on sliding friction. A dent in a hard steel ball, formed by driving a greater than 600,000 pounds per square inch pocket of liquid into the ball on impact with a sapphire plate, is shown in this interferogram. Such dents may be used to texture surfaces for the reduction of friction. At Georgia Tech, researchers have designed a specialized instrument for the study of elastohydrodynamic entrapment. The sapphire disc is loaded against the steel ball by solenoids, and the contact is imaged through the microscope. Friction is measured as the disc is slid against the ball. Laboratories at the University of Illinois at Urbana-Champaign are specializing in the study of the influences of nanoparticles and nanosurfaces on fluid flow and tribology. The Environmental Scanning Electron Microscope, or ESEM, is an essential tool for observing surface morphology. The purple vials contain various solutions with carbon nanotubes and/or polymer additives for Project 1G2 that are about to be processed in the ultrasonic processor also seen on this bench. This is an ESEM image of bundled carbon nanotubes in a water solution. And here, the carbon nanotubes have been dispersed after a polymer has been added to the solution. Fluid drag measurements reveal that the solution with dispersed carbon nanotubes has lower drag and the transition to turbulence has been delayed. The sputterer is used to deposit a thin layer of gold nanoparticles onto nanocomposites to functionalize them for viewing in the scanning electron microscope. The surface profile is measured using a profilometer. Contact angles are a measure of surface energy between a droplet and a substrate. Static contact angles are measured using a goniometer. These contact angle measurements are of superhydrophobic and superoleophobic nanocomposites. The sliding angle is measured using a digital inclinometer on a pivoting stage, producing results such as these obtained by measuring contact angle hysteresis, the difference between the advancing and receding contact angles. A high-speed camera is an essential tool for understanding dynamic contact phenomena, as shown here in the sequence of high-speed images of a droplet bouncing on a nanocomposite surface. Particle image velocimetry is the measurement method used in the cavitation test stand at Purdue University to obtain instantaneous velocity measurements in the flow field. A close-up of the experiment shows bubbles being formed by cavitation. The various test stands in the Maha Fluid Power Center at Purdue University perform valuable experiments to help understand fundamental phenomena in hydraulic pumps and motors. These stands include a piston pressure test stand, a piston friction test stand with its associated data acquisition system, a pump temperature test stand, and a pump efficiency test stand. The Milwaukee School of Engineering has a 200 horsepower hydraulic dynamometer with electrical regeneration. Electrical regeneration reduces electrical energy use and cooling water consumption, while providing precise low-speed, high-torque hydraulic motor control. This facility is the first facility of its type at any university. The stand uses a constant torque AC motor to provide the load required to evaluate fluid-related torque and leakage losses within a hydraulic circuit. A hydraulic orbital motor, like the one seen here, is used for testing in the dynamometer. The experimental facilities of the Center for Compact and Efficient Fluid Power provide unmatched capabilities for fundamental research in tribology and fluid flow related to fluid power.